Today our topic is how do we write a formula for a chemical compound from its name. So the first thing we've got to keep in mind when we are writing formulas for names is that, remember, different types of compounds are named differently. All right. So first of all, let's keep in mind, ionic compounds, we recognize an ionic compound because it's a metal bonded to a non-metal, or a metal bonded to a polyatomic anion. So you've got a positively charged cation, negatively charged anion, they are attracted to one another, and that forms an ionic compound. When you are writing formulas, you have to keep in mind that they are electrically balanced ionic compounds. Overall positive charge is equal to the overall negative charge. Covalent compounds, we recognize them because they are nonmetals bonded to nonmetals. All of the elements in a covalent compound are nonmetals. They share pairs of electrons. They are not electrically balanced. That is not the nature of their bond. So we don't worry about positives being equal to negatives. Instead, remember, we use Greek prefixes. Mono, di, tri, tetra, penta, etc. And finally, the last kind of compound we've looked at is acids. Okay, that's a hydrogen bonded to a nonmetal or polyatomic anion. They are electrically balanced. The number of positives have to equal the number of negatives overall for that thing to stay together and be a stable compound. I'm going to go to the board and let's do some practice. So I'm going to give the name magnesium chloride. How do I write the chemical formula for this compound? First thing I need to identify is what kind of compound is it? Metal, non-metal. Ionic compound, meaning that when I write this formula, I am going to have to electrically balance this thing. So I'm going to start with the charges on both of these. You'll need your periodic table. You are also going to need your ion cards for this. Magnesium is in group 2, so magnesium has a positive 2 charge. Okay? And chloride is in group 7. Chloride has a negative 1 charge. Okay, are my two equal? No, they are not. I've got a positive 2, I got a negative 1. So that means I'm going to need 2 chlorides so that I have an overall negative 2. How am I going to write this thing then? I'm going to write it Mg, right, I'm going to use its symbol, Cl, and because I need 2 of them, 2. Right? I've got to multiply this thing by 2, so that now I've got negative 2 and positive 2. MgCl2. That's what the subscript is for, to electrically balance this thing. All right, let's try another one. Iron 3 oxide. Ooh, gotta love this. Transition metal tells us the charge. So, iron, well, first first of all, what kind of compound is it? I'm going to do all ionics first. So, metal, non-metal, it has to be electrically balanced. So, iron 3, so iron 3 has got a positive 3 charge. Oxide, oxygen is in group 6 on the periodic table, it's got a negative 2 charge. Okay. They have to be equal. They have to be equal. So what are we going to do? There's not one number that we can multiply just one of these by to make it equal. We have to multiply 2 of them, both of them. So this one, if we multiply it by a 3, that'll give us an overall negative 6. And this one, what should we multiply it by? 2, right? So that means we will have Fe2O3. This 2 does not mean it's iron 2. This 2 means that we need 2 irons with a positive 3 charge to balance 3 oxides with a negative 2 charge. Fe2O3. How about lithium phosphate? Lithium phosphate. Lithium is in group 1, it has a positive 1 charge. Phosphate is polyatomic, we know it. Well, we should. PO4 negative 3. Alright, so how many lithiums do we need to electrically balance this negative 3? We need 3 of them, right? We need 3 of them. So, this thing's going to be Li3P. Okay. Ammonium sulfate. Ammonium is a polyatomic ion. It's the only polyatomic cation we have for ionic compounds. Okay, so it's NH4+, so it's got a positive 1. Sulfate has got a negative 2. So that means to balance my negative 2, I'm going to have to multiply this thing by 2. So it leaves me, I need 2 ammoniums. NH4, and I need 2 of them. So I'm going to use parentheses when I have something polyatomic. I don't have anything else polyatomic here where I need more than one of them. So this one, right? I need 2 whole ammoniums and then sulfate, SO4. Notice, people, I don't use parentheses any other time. The only time I'm using parentheses is if I have something polyatomic and I need more than one of them. I have to denote that I need more of this whole thing. That's where I'm going to use parentheses. Alright, let's move to something that's a little bit easier, and that is going to be writing the covalent compounds from their names. Easy peasy. Okay, how about trisulfur heptachloride? sulfur heptachloride. Whenever I see these prefixes, I say, woo, yay, because that means I don't need to electrically balance anything. This is a covalent compound. So all I need to do is translate my prefixes. Sulfur is S, tri is 3, chloride is Cl, hepta is, I think, 7. That's it. That's all you do, covalence. Alright, last but not least, let's do a couple of acids. Hydrofluoric. Hydrofluoric acid. Alright, now, if it's an acid, the cation is what? It's always going to have a cation, that's hydrogen. Okay, I'm going to do this a little bit differently here, you guys. Okay. Hydrofluoric. So if it's hydro, it's got a prefix, that means that it is simply the fluoride ion. I almost wrote FL. Okay, fluoride has got a -1 charge. Fluorine is in group number 7, and so when it forms ions, always have a -1 charge. Okay, is it balanced electrically? Positive, a negative, +1, -1. So I can leave it just like this, you guys. It's H, F. Nitrous acid. Nitrous acid. Okay, whenever I've got an acid, that means that hydrogen is going to be my cation. Nitrous. No prefix. That means it's an oxyacid. Us is ite. Nitrite. Nitrite. NO2, -1 charge. My positive and negative, in this case, balance. +1, -1. So I simply write it HNO2. Okay, what about sulfurous? Sulfurous acid. Acid, H+, sulfurous. Okay, so no prefix here. So us becomes ite, and so it's sulfite. SO3, -2. -2, +1. How many hydrogens do I need to balance this -2? You need 2 of them. So this thing will end up looking like H2S